Hi guys, welcome to this screencast on the muscular system for Tuesday's lesson. So first of all, your corner notes needs to look like this. What we're talking about today, we're going to be discussing the agonist, antagonist, fixator, concentric contraction, eccentric and isometric. So if you can get that down on your notes, that'd be brilliant. Thank you. Right, okay, in the email that I sent you, I also sent you a Word document of this anatomical figure. What I want you to do with that is create your own lines and get these muscles down. I'll quickly talk through them. We need to know how they're pronounced and what they look like. So for example, your pecs, you will not get any marks for pecs. It has to be pectoralis major, and that this muscle here. Instead of biceps, we have to know it's biceps brachii. That is how we have to write it. You will not get any marks for biceps. So we've got external obliques here, wrist flexors. So wrist flexors, obviously they flex the wrist, so they cause wrist flexion. Tibialis anterior is this one on your front, okay, and that does dorsiflexion. Rectus femoris instead of quadriceps, so no longer can you put quadriceps, you have to put rectus femoris, which is this muscle here, and that flexes the knee. Adductor longus in here, movement is adduction. Rectus abdominis, so not abdominals anymore, or abs, it's rectus abdominis, which is essentially the six-pack. You've got anterior deltoid, so it's the front view. Anterior means front, so you've got the anterior deltoid. Okay, in the rear view, the posterior view, we've got posterior deltoid here. Triceps brachii instead of just triceps. Latissimus dorsi, gluteus medius, and gluteus maximus. Your biceps femoris here, which is your hamstring, but you need to know it as biceps femoris. Gastrocnemius, and then soleus. Soleus runs under the gastroc, starts here, but it runs under the gastroc, and that's called soleus. Wrist extensors, teres major, trapezius. So if you can get that down on the Word document I sent you, I'll be grateful, thank you. Right, okay, so antagonistic muscle actions. So we need to know that muscles never work on their own. They always work in pairs or a group, and this is to help produce movement. And then each muscle takes on a different role depending on the type of movement produced, and this can change. Okay, there are three main roles that we need to discuss, and these are agonist, antagonist, and fixator. So the agonist, a muscle responsible for creating movement at a joint, also known as the prime mover. So that muscle that is creating the movement at a specific joint. The antagonist, you have a muscle that opposes the agonist, providing resistance for coordinated movement. This is usually the opposite muscle, and I'll go through a few examples in a second. And then fixator, a muscle that stabilizes one part of the body while another causes the movement. So an example for your agonist and antagonist, for a bicep curl, so elbow flexion, the biceps brachii is going to be your agonist, and the triceps brachii is going to be your antagonist. If you're doing a wrist curl, so you work on your forearms, the wrist flexors are your agonist and your wrist extensors are your antagonist, the muscles in opposites working together. That's just a quick brief overview, and we'll go on about that in lesson. Okay, muscular contractions now. Again, there are three muscular contractions we're concentrating on, which is concentric, eccentric and isometric. Now, under concentric and eccentric fall under an isotonic contraction. So an isotonic muscular contraction is when a muscle changes length during its contraction. So if a muscle changes length during a contraction, it is known as an isotonic contraction. You don't really need to know about isotonic necessarily. It's the two parts that are underneath it, which are concentric and eccentric. So concentric contraction, muscular contraction, which shortens while producing tension. So the muscle shortens in length. That's a concentric contraction. An eccentric contraction, muscular contraction which lengthens while producing tension. And then finally, an isometric contraction, that is muscular contraction which stays the same length while producing tension. So for example, during the upward phase of a bicep curl, so you're doing elbow flexion, a concentric muscle contraction is happening at the biceps brachii, i.e. the biceps brachii is shortening. Now on the lowering phase, which is controlled lowering phase, the biceps is still the one that's contracting, and the biceps brachii is still the prime mover in that. However, it is eccentrically contracting. It is getting longer in length during that contraction. If you're watching this right now, if you just do elbow flexion, put your arm on your biceps brachii. If you do flexion, you can feel your biceps brachii getting shorter. When you lower it down extension, you can feel the biceps brachii getting longer. That is an eccentric contraction. Then isometric, an example of that would be holding a squat. So your muscles are in tension, but they are not changing length. They're staying the same length during that tension. And this is just the example of concentric muscular contraction, so it's shortening. Isometric, it is staying the same length, so it'd be holding something in that position. So holding a dumbbell in that position is an isometric muscular contraction. There's no movement within the muscle. On the lowering phase, it's getting longer, eccentric contraction as the biceps brachii lengthens to control extension of the elbow. Right, okay, so that's all you need to get down, and I'll see you in lesson on Tuesday. Thank you, bye.